So we're going to continue looking at the ambiguous case of the law of sines. And we have to look at we have to name our parts. We have a given angle, a side opposite the given angle, and the other given side. The number of triangles we're going to get is going to depend on the side opposite the given angle, how it compares to the height of the triangle and the other given side. If the side opposite the given angle is less than the height, then we have no triangles and we're done. That's nice. If the side opposite the given angle is exactly equal to the height, then we get exactly one right triangle. Perfect fit. If the side opposite the given angle is greater than the height but less than the other given side, then we can imagine putting two triangles together. Just imagine that side opposite the given angle swinging back and forth and hitting the line where the third side goes 2 times to make 2 triangles. But we stop being able to do that if the side opposite the given angle is greater than the other given side. Then trying to put a second triangle in there. When we swing the side opposite the given angle back and forth, it goes completely around. And we only end up with one triangle way over here. Way over here. So the point we start getting triangles is when the side opposite the given angle is equal to the height. Fortunately for our heroes, we can actually calculate the height of this triangle because we have the other given side and this given angle. Notice that the height, the shortest distance from the other given side to the line where the third side goes, the height, forms a right triangle where the other given side is the hypotenuse and the height is opposite the given angle. So we can calculate the height as the other given side times the sine of the given angle. So if we're worried that the side opposite the given angle is going to be too short, we can calculate the height and actually find out. Let's take a look at an example, and then we're going to change the values of the side opposite the given angle. So we're going to start with a given angle. We're going to set up another given side, and then we're going to vary the values of the side opposite the given angle and see what we can see. So let's start with a given angle. Let's say alpha is 57 degrees. Okay, 75 degrees. I spelled 57 wrong. Wait, how do you spell 57? Is it 7 first? It's like an I before E situation. You shouldn't get that wrong in numbers because the numbers freaking tell you. That's fine, that's fine. We'll just go with 75. And let's see, the other given side. So A is the side opposite the given angle. So I just need to pick one of the other given sides. So I'm going to say B, side B is equal to 10. Let's use centimeters because I don't want the triangles to get too big. And so that means A is going to be the side opposite the given angle. So the 75 is our given angle. The 10 centimeters is our other given side. And A, since alpha is given angle, A is the side opposite the given angle. I'm going to start with a sine opposite the given angle of, let's say, 8 centimeters. Since the side opposite the given angle is less than the other given side, we're in the 0, 1, or 2 triangles scenario. One thing that we can do is calculate the height of this triangle to see. One thing we can do is calculate the height of this triangle to see how many triangles we're going to get. So let's calculate the height. It's going to be the other given side, 10, times the sine of the given angle. So 10 times the sine of 75 is 9.7. Now that we've calculated the height at 9.7, that's the minimum value this is why I wanted to use 57. That's the minimum value to have a triangle at all. So if the sine opposite the given angle, since it is less than the height, we get no triangles. So the side opposite the given angle at 8 is less than the height, so we have 0 triangles. The side opposite the given angle is less than the height. So the ruling on the field is no triangle. And then we're done. There's no point in looking for anything else. We know that there is no answer. Let's suppose that we didn't recognize that. Let's suppose that we didn't stop and calculate the heights, and we just tried to proceed. Suppose we didn't notice. Let's pretend that we didn't calculate the height, and we're going to start solving this problem completely unaware that there is no triangle. We have a set of opposite information in A and alpha, so we'll use the law of sines to find our first angle. That's another hint that we should be checking to see if there's even a possibility, but let's just ignore that. Let's say the sine and use the law of sines. Sine of alpha over A is sine beta over B. And we're going to use this to find beta. So the sine of 75 over A is equal to the sine of beta over B. So beta is the sine inverse of 10 sine 75 divided by 8. We're using the law of sines because we have a set of opposite information. It's the first thing that we're doing, and we're using it to find an angle. So we know we're in the ambiguous case, but we're just ignoring all that and saying calculations will save us. Save us calculations. What is the sine inverse of 10 sine 75, the height of our triangle, divided by 8? We get a domain error. The calculators are all, did you not notice that you were the ambiguous case and that the height of the triangle was greater, or sorry, that the side opposite the given angle was less than the height of the triangle? And you're like, oh no, I didn't, because I don't know what the sine of 75 is offhand. So what happens when we try to make this calculation is that we get a domain error. The reason that we're getting a domain error is that 10 sine 75 divided by 8 is greater than 1. Ten sine 75 divided by 8 is greater than 1. The reason that 10 sine 75 over 8 is greater than 1 is that the height, which is 10 sine 75, is greater than the other given side. And that's why we have no triangle. The side opposite the given angle is just dangling from the other given side. So it's a domain error because the side opposite the given angle is less than the height. Here's the height. Eight is the side opposite the given angle. And the height divided by the side opposite the given angle is less than 1, or sorry, is greater than 1. If I multiply both sides by the side opposite the given angle, that's telling us that the height is greater than the side opposite the given angle. Or stated the other direction, the side opposite the given angle is less than the height, which means no triangles. So if we don't recognize right away that we're in the no triangles case, it's okay. As soon as we get a domain error, because we're using the law of sines to find an angle, and it's the first thing, we get reminded. So we see this domain error, it's like, oh, hang on a second. Does that mean there's no triangle? We check the heights, we check the side opposite the given angle and say, oh man, there's no triangle. Any questions? How's everybody okay? Let's go to the opposite. Here's a case where we recognize that we're going to be using the law of sines to find our first piece. We're going to use law of sines as our first move. Find our fourth part of the triangle. And we're going to be using the law of sines to find an angle. So we do have to worry that we're in the ambiguous case, but we see that the side opposite the given angle is greater than the other given side, so we know that there's one triangle. So here's the case where if you didn't recognize that you were in the ambiguous case, you still only got one triangle and the numbers worked out anyway. So this works in your favor. We don't have to worry about the height because the side opposite the given angle is greater than the other given side. Here's our solga. So we're not worried about the height because we see that the side opposite the given angle is greater than the other given side. So there is one triangle. If we didn't notice this, it won't matter because there's only one triangle and we're about to find it. We'll just use the law of sines. Take the sine of alpha over A is the sine of beta over B. So the sine of 75 over 12 is sine of beta over 10. So beta is the sine inverse of 10 sine 75. There's the height again. Divided by 12. Now we're definitely doing the sine inverse of something less than 1 because 12 is bigger than 10 sine 75. So beta is 53.6 degrees. At this point, as soon as we have as soon as we have two angles, we should subtract to find the third angle. Once we have the third angle, we can just use the law of sines again to find the third side. Any questions? How's everybody okay? It's kind of difficult and very suspicious if I set this up to give you one right triangle. Because if we're going to build a right triangle, the sides are going to be like all 1, 2, and the square root of 3. So if I'm like, oh, one of the sides is the square root of 3. The hypotenuse is 2, and this side is the square root of 3. Maybe I go, that's very suspicious. Let me guess, the angle is 60 degrees. Yes, how did you know? Because you have to give us a right triangle, and one of them is going to be irrational. Or the angle is going to have so many digits in it so that our calculators can tell that we're supposed to come up with 90. It's kind of hard to set up without being super suspicious. All right. So the other case that we might run into where we're going to have to do some work is the two triangles case. Strangely enough, I'm not going to do an example where you do the two triangles case. I'm going to leave that hanging over the weekend. This is called a cliffhanger. It's less effective in a math class than it is in like a dramatic television show. You're like, oh my gosh, what's going to happen? That just doesn't, you don't get that feeling in a math class. It's like, oh wait, how are we going to solve if there's two triangles? Oh, I guess we will find out, like the credits roll. Like, no, right? I don't even know if that's effective anymore because now entire seasons of the show are on. So it's like, oh, I have to wait for a whole week. It's like, oh, wait, no, I just have to fast forward to the credits. Watch the next episode. You know what I mean? Like there's binge watching that. But I guess some streaming services kind of like artificially slowly release all the episodes. You know what I mean? It's like, oh, you'll have to wait till next week. And most people are just waiting for the entire season to finish loading and then just start binge watching. It's like, aha, suck it, Paramount. I'm going to watch it all at once anyway. And then you binge Star Trek or something like that. Like, well, just put it all on there at once. So I don't have to friggin' wait. You know what I mean? It's kind of annoying because they're services that we pay for. It's like, I'm already paying you to do this. So you don't need to get money from the advertisers. Keep me engaged with the material. You know what I mean? But some of them like, oh, what if we have people pay for the service and we show them commercial? And I'll do that's fucked up. Here's the thing. If it's going to be the two triangles case, just take that first angle that you found, put it in the second quadrant. The great thing about this, if you're using the law of sines, if you're not sure if it's going to be two triangles or not, just put the first angle you find into the second quadrant and keep going. When you get to the third angle, if it comes out negative, it's like, oh, I guess it was a one triangle case. The numbers will tell you how many triangles there are. You just need to know how to proceed. Use the law of sines. If you're using the law of sines and you know you're in the ambiguous case, put the first angle you find into the second quadrant and then proceed with two triangles. So for example, if I take this 53.6 and I put that into quadrant 2, let's see, so I'd have 180 minus 53.6. That means my other angle will be 126.4. Well, that's not going to fit. I can't make a triangle with a 126.4, a 53, and a 75. Just put that first angle you find, put it into the second quadrant, see if you can make a second triangle. All right. So I didn't do a whole example, but you can probably guess what we're going to be doing on Tuesday. It's not a cliffhanger if I give you the spoiler before the next episode, but that's also very traditional in modern media, where if you just watch enough trailers, you've seen the movie. You know what I mean? Incidentally, the first instance was a trailer spoiling its own movie was Mission Impossible. In Mission Impossible, like the big stunt, the big thing is the helicopter in the tunnel. And I know it's like, oh, but I haven't seen Mission Impossible. If you've seen the trailer, then you have seen this part of Mission Impossible. The helicopter gets hooked onto the train, and Jean Reno has to fly the helicopter in the tunnel. It's pretty awesome, but we already knew it was going to happen because of the King trailer. And we knew the helicopter was going to blow up, and Tom Cruise was going to get thrown by the explosion onto the train. We knew that was going to happen because it was in the trailer. It kind of took something out of it when we got into the tunnel, because like when he's flying the helicopter, he's like, well, haha, it's hooked onto the train. Oh wait, but I already know he flies the train into the tunnel. Even though in the movie it's like super badass, he's like, oh no, I'm stuck, and he's just like, oh, I'll fly into the tunnel, and we should be like, oh, whoa, but we already knew it was going to happen, so it really sucked some of the wind out of that sail. And then we're like, oh no, Tom Cruise, what are you going to do? That you're on the helicopter, you're going to need to be on the train. And it's like, oh, that's right, the helicopter is going to blow up and fling him onto the train. Because you saw that in the trailer. Stupid trailer. You know what I mean? Same thing happened in Batman. You watch the trailer. Oh, Gordon's not dead. Sorry, that's not a spoiler, by the way. The statute of limitations is fucking passed on that. Darth Vader is Luke's father. There's a statute of limitations. If you haven't seen the one where they try to fool you and you think you're like, oh no, is Gordon dead? No. Watch the trailers. Like, oh wait, they showed him in the police station after this, so it was already a spoiler. You know what I mean? That's all beside the point. So, spoiler alert. That first angle you find, put it in the second quadrant and just try to find two triangles. Because once you do that, you have two angles in both of those triangles. Subtract to find the third. If one of them comes out negative, it's like, oh, well, that wasn't a thing. And then you proceed with the first one. That's going to do it for today. I will see y'all on Tuesday. Everybody have a good weekend, and thanks for playing.